So today we're going to cover multiplication or multiplying fractions. Now, if you notice your rule here in this little box, it's got an example of multiplying two simple fractions. So when we multiply fractions, we're going to multiply the numerator by the numerator and the denominator by the denominator. Now, I highly recommend that if you can simplify before you multiply, it'll make things a little bit easier. Now, in this particular box here, they just went ahead and multiplied the fractions as is. There was nothing to simplify. But I'm going to show you example 1, either just multiplying it as is, and then also by multiplying it by simplifying before you multiply. So for example, if we took the problem, 8 over 9 times 3 over 10, and I multiplied it as is, I would get 24, 8 times 3 is 24, and 9 times 10 is 90. Now at this point, I would need to reduce this. And I could divide them both by 6 and be left with, which is my GCF, divide the top and the bottom by 6 to simplify the fraction to 4 over 15. Now the other way you can do this is you could either simplify diagonally like you probably learned in 4th grade, or we could also factor these and make one big fraction bar. So for example, I could take the 8 and make this 2 times 4, or 2 times 2 times 2 over 3 times 3. And then here I have a 3 over 2 times 5. And then I can cancel the common factors. So a 2 and a 2, a 3 with a 3, and then I don't have anything else left that I can cancel out, and I'm left with 4 over 15. Now you could also do it the way that you did in 4th grade, 8 over 9, 3 over 10, and you can look for something to make 3 goes into this 1 time, 3 into this 3 times, 2 goes into this 4, 2 goes into this 5, and then multiply what remains. However, our problems are going to get a little bit more difficult, and the goal here is to factor them first. So let's try example 2. So for here, I've got 6x, and then I'm going to expand the y to the third, and I'm actually going to make it y times y times y, and then here, y times y, and then the 15 can factor into 3 times 5. And actually, I'm going to break the 6 into 2 times 3. So now I'm going to look for things to cancel. So before I multiply. Now I'm going to also show you multiplying it as is. So here I'm going to cancel. I can cancel a y, 2 y's here, the 3, and then there's nothing else left to cancel. So now I'm left with 2x over 5y. Now, if you prefer 6x, y to the third, you're going to get really good where you're going to be able to look at this and say, okay, I've got 2 y's here. I could take 2 y's out of this and leave behind 1. You could simplify the 6 and the 15. 3 goes into 6 twice. 3 goes into 15 5 times. And now multiply what's left over. Either way. The next one, b here, I need to factor all of the pieces. So again, remember, the instructions are to factor the numerator, factor the denominator. So what I'm going to do is factor the first one, so that trinomial, x minus 4, x plus 3. The denominator, I'm going to pull a GCF out of x. The second fraction, I'm going to make it x minus 5, x plus 5, the difference of 2 squares, over x plus 3. Now remember, when you're multiplying, you're going to multiply the numerator by the numerator. So what I could do is take away this dot here and make this one big fraction bar. And now I'm going to look for something to cancel in the top that's also in the bottom. So notice I have an x minus 5 and an x minus 5. I also have an x plus 3 and an x plus 3. And now what remains is the x minus 4, the x plus 5, this is all in the top, over x. I cannot cancel out the x because, again, notice the grouping symbols around the x minus 4 and the x plus 5. If I were to try to cancel this x, it would have either needed a minus 4 or a plus 5 with it. So this would be your final answer here. All right, let's try. See what else we have here. So now on this one, we have the rule of exponents for power of a quotient. So in this rule here, this exponent of m is going to distribute to both the a and the b. Now, up here, they're talking about a power of a product. Just know that when you have something that's being multiplied, you're just going to, again, distribute the power to both the A and the B on this one also. Now, in last night's homework, remember there was some restrictions. Again, this instructions on this homework is it's going to say to assume that all values are valid. It wouldn't make it undefined. But again, here it's talking about what would make the denominator 0. We will cover this later when we get into solving rational equations, and we will have to list the excluded values. But for now, we're just going to multiply and simplify. So let's go ahead and try example 3. And here it has, we're going to apply the rule of exponents for power of a quotient. So we're going to take this exponent of 3 and we're going to distribute it to both the numerator and the denominator. So this will become x to the third over 3 to the third. And on this one, I can actually evaluate 3 to the third and get 27. On this particular problem, I need to distribute the 2 to the c and to the -2. Now, on this one, notice when we're squaring a negative number, this is actually going to become positive now. So notice we're following order of operations here. We're going to apply the parentheses, then exponents, and then we'll actually multiply. So now here, I'm going to see if I can simplify anything before I multiply. Notice I can simplify the 4s. And then here, I could take a c away. And then I'm left with c over 3. Now, if you prefer to factor it, remember again, we can also write this as c. I'll do it down here. This could have factored into c times c over 2 times 2. And then over here, 2 times 2. And then 3 times c. So again, look for things to cancel. A c and a c, a 2, a 2, a 2, a 2. And then anything that's not canceled out, which is the c and the 3, and there's your answer. So that is multiplication and applying the power rule of a quotient. Let's see if I can do another example here from the oral exercises. So the beginning ones are pretty simple. I know you've seen those before. So let me try one of the more challenging ones down here. Let's try number 12. So for number 12, I am going to take 3n minus 2. I can't factor anything there. The n to the 4th, again, if you like to do the factoring, I could do here n, 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 and then here n times n for the n squared, and then times 2 minus 3n. Now, notice these look the same, sort of. What I'm going to do is I'm going to pull a GCF out of -1, and then it'll look the same. So if I divide out a -1 GCF, now it looks the same, and now I can start canceling. This will cancel, this will cancel, and now I'm left with n squared over -1, and then I can divide that and get -n squared. Now, for those of you who remember division from 4th grade when you learned how to divide fractions, remember the process is the same. The only difference is you're going to take your second fraction that you're multiplying and flip it upside down. Okay, and that's what we're going to cover tomorrow is the division. Okay, so your homework for this lesson is going to be 4 through 54 even. You're going to skip numbers 30 through 34.